Welcome to this explainer. Today, we're diving into something absolutely wild, the 70-year roller coaster ride of artificial intelligence. We're going to look at its foundational concepts, its massive booms, its freezing winters, and ultimately, where this whole thing is actually heading. So whether you're a tech veteran or just trying to figure out what the future holds, buckle up, we've got some fascinating ground to cover.
Let's get things off with a question that seems super simple, but really isn't. What exactly is artificial intelligence? We generally picture it as some artificial object with human-level reasoning and judgment. But once you actually dig into the research, the definition is incredibly, slippery. It's really not as universally agreed upon as you might think.
Actually, it's pretty mind-blowing. Even the world's absolute top experts can't agree on what AI actually is. Look at John McCarthy, literally one of the founding fathers of the field. He called it simply a machine. Professor Yutaka Matsuo, he calls it a technology. And then you have Professor Minoru Asada, who argues that it's just straight up undefinable right now. It's fascinating, right? The very people building the future don't even have a single shared definition for it.
So here's our roadmap for today. 1. Defining the undefinable. 2. A history of booms. 3. The illusion of understanding. 4. Invisible walls and challenges. And 5. Approaching the singularity. Let's jump right in.
Section 1. Defining the undefinable. The shifting goalposts of machine intelligence. Have you ever noticed that the second a computer actually masters a really hard task, we suddenly stop calling it intelligent? Yeah, that's a real documented psychological quirk called the AI effect. Basically, we humans love to move the goalposts. Once the machine solves the problem, we just wave it off as mere automation, rather than genuine intelligence. Deep down, I think we're just incredibly hesitant to admit that a machine can actually do what we do.
To clear up some of this mess, researchers split AI up by how complex it is. First, you've got general AI. Think of sci-fi or anime, like Doraemon, an AI with actual consciousness that can juggle multiple different domains just like you or me. But here's the reality check. Literally all of our current mainstream tech is narrow AI. It's built to be exceptionally good at one specific thing, whether that's recognizing images or driving a car. No general consciousness, just extreme focus.
Moving right along to Section 2. A history of booms, the roller coaster of technological progress and winters.
Now, a lot of people think AI is this brand new thing, but the story actually kicks off way back in 1946 with ENIAC, the world's first massive computer. A few years later, in 1950, Alan Turing came up with his famous Turing test, simulating conversation to measure machine intelligence. Basically, if a human judge couldn't tell if they were chatting with a human or a computer, the computer was deemed intelligent. Then, boom, 1956, at the Dartmouth Conference, the actual term artificial intelligence is finally born, a totally momentous occasion.
Since then, it's been this crazy cycle of massive hype, what we call booms, followed by devastating winters. The first boom in the 50s was all about search and inference, but it kind of flopped in the real world. The second boom hit in the 80s with expert knowledge systems, but those ended up being way too expensive. Then the 2000s brought the third boom with deep learning. And that reads us straight to right now, the post-2022 fourth boom, the explosive era of generative AI.
What actually dragged AI out of its winter during that third boom was a fundamental shift in how computers learn. See, in older machine learning, humans had to literally hand-feed the features or the rules to the AI. It was exhausting. But with deep learning, the AI uses a multi-layered structure to figure out and extract those key features all on its own from massive datasets. Add in the explosion of internet data and crazy fast GPUs, and the entire landscape changed almost overnight. Let's jump to Section 3, the illusion of understanding, processing power versus genuine comprehension.
To really grasp this debate, we have to talk about a brilliant 1980 thought experiment by John Searle called the Chinese room. Imagine you're locked in a room. Someone slides pieces of paper with Chinese characters under the door. You don't speak a word of Chinese, but you have a massive English rulebook that tells you exactly which characters to slide back out in response. To anyone standing outside, it looks like you completely understand Chinese, but inside, you have zero clue what you're saying. Searle used this to argue that insane processing speed is really just following a manual. It absolutely does not equal true intelligence.
And that thought experiment perfectly highlights the gap between strong AI and weak AI. Strong AI, which guys like Searle and Roger Penrose thought might literally be impossible, has actual true consciousness and understanding. Weak AI, on the other hand, just solves specific problems without any self-awareness whatsoever. So even when IBM's Deep Blue crushed the human world chess champion back in 1997, it was an incredible achievement, sure, but it was ultimately just a highly advanced weak AI. It didn't know it was playing chess.
Okay, Section 4. Invisible Walls and Challenges. The Profound Hurdles Facing Modern AI.
Despite all the hype today, there are some massive roadblocks. One of the oldest is the frame problem, pointed out by John McCarthy way back in 1969. In a simple contained game, AI is a genius. But the real world is chaotic. It's infinite. The frame problem is a machine's inability to instinctively filter out useless information. It literally struggles to draw a frame around what actually matters in a messy, unpredictable reality, something your human brain does effortlessly without you even realizing it.
Here's the classic example of this, and it's kind of hilarious. Imagine a robot tasked with getting a valuable battery out of a room that has a ticking bomb in it. The robot tries to calculate the absolute safest route, but lacking human instinct, it starts analyzing every single variable in the room. I mean, totally absurd stuff like calculating if the color of the paint on the ceiling is going to somehow affect the battery. It gets completely overwhelmed by infinite irrelevant possibilities. It literally freezes from overthinking, and boom, the bomb goes off.
And that perfectly sets up another major hurdle, Moravec's paradox. This is the completely wild, counterintuitive reality that high-level logical stuff, like complex math, is super easy for an AI. But everyday physical tasks that a literal toddler can do, like walking across a room or grabbing a cup, incredibly difficult for a machine. Why? Because AI totally lacks the physical body and sensory experience that we humans use to effortlessly navigate the physical world. Which leads right into the symbol grounding problem. This is what happens when an AI has an encyclopedic knowledge of words or symbols, but zero physical context to tie them to. For instance, an AI can read text data explaining that a zebra is a horse with black and white stripes. It knows that definition perfectly, but without ever having seen one or having visual and physical context, it fundamentally struggles to actually conceptualize or picture that animal in the real world.
So, when you smash the frame problem, Moravec's paradox, and the symbol grounding problem all together, you hit what researchers call the common sense bottleneck. Honestly, teaching a machine the basic common sense that we just take for granted is still one of the single biggest roadblocks in modern tech. It messes with everything from making a robot walk naturally to getting a perfect language translation. It's exactly why your GPS might occasionally tell you to drive straight into a lake. It just doesn't have that baseline human common sense. Let's move into our final section, Section 5, Approaching the Singularity, When Machines Surpass the Creators. 2045. That number is probably one of the most famous or maybe infamous dates in the entire tech world. It's the year that prominent futurist Ray Kurzweil famously predicted humanity is going to hit a massive technological point of no return. That point of no return? It's called the singularity. It's this theoretical tipping point where tech progress doesn't just grow, it accelerates exponentially. AI surpasses human intelligence, and our entire civilization gets fundamentally transformed. And look, this isn't just late-night sci-fi stuff. If you go to the top AI summits in the world right now, places like CVPR, NeurIPS, and III, the smartest people on the planet are relentlessly pushing the boundaries of machine learning to make this exact reality happen.
But building the tech is really only half the story. Sure, technology scales up exponentially, but human society, we definitely do not. Even if an AI's brain power suddenly vastly exceeds ours, baking that into our daily lives is going to take an enormous amount of time. Plus, let's be real, our legal and regulatory frameworks are notoriously slow. They're guaranteed to lag way behind what the software can actually do.
Which leaves us with one final, totally critical thought to chew on. We've looked at the 70-year roller coaster, the explosion of generative AI, and those invisible walls researchers are still trying to break down. The tech is accelerating, absolutely no doubt about it. But when the singularity actually knocks on our door, will our laws, our ethics, and our society actually be ready to answer? Thank you so much for joining me for this explainer. The future is arriving way faster than we think. The only question is, are we ready for it?